while reviewing the next-generation drone landscape. A recurring theme stands out: the desire for a device that merges immersive capture, aggressive flight control, and intelligent processing without sacrificing durability, range, or ecosystem compatibility. Few companies have dominated aerial imaging like DJI, a Shenzhen-based technology giant renowned for shaping the prosumer and professional drone segments through reliability and relentless iteration. The original market entry that pioneered DJI's exploration of the first-person view segment was the DJI FPV, an integrated package combining stabilization and modular controls, but initially criticized by seasoned pilots for high cost, fragility, and limited mass appeal, ultimately resulting in its discontinuation despite its engineering ingenuity and bold concept. This was the moment DJI realized that innovation alone is not enough. The FPV market is one driven by trust, agility, unit economics, pilot culture, and perceived value for investment. DJI's comeback to address these shortcomings arrived in 2021 with the release of the DJI Avata, a Cinewhoop-style quadcopter featuring full propeller guards that prioritized crash resilience, everyday practicality, and cinematic stabilization, slowly shifting opinions in enthusiast communities that had once rejected the previous model entirely. However, true validation and mass adoption of the Avata line happened later when DJI launched the DJI Avata 2, which significantly improved camera clarity, processing reliability, gyro-based stabilization, acceleration control, and pilot experience, finally resonating with more skilled operators who now saw it as a legitimate creative tool, not just a novelty. Yet, even after these milestones, DJI knew that market leadership thrives not on maintaining the status quo, but on rewriting expectations at the precise moment competitors attempt to redefine the technological benchmark. That defining challenge arrived when the drone world was jolted by leaked reports of a rival concept, the Anti-Gravity A1, a theoretical 360 drone prototype scheduled to arrive January 26, sparking debates over who would truly deliver the first mainstream hybrid drone capable of spherical capture without structural compromise. DJI's reply was swift and strategic. New leaks revealed that DJI had been testing a 360 capable prototype internally long before the public ever realized, cleverly hiding the dual spherical camera module by positioning the drone's gimbal to rotate downward upon landing for lens protection. The early grainy leaks teased months ago were not incomplete prototypes but deliberate misdirection to protect design secrecy. Then, on August 2025, another set of images surfaced in higher fidelity, showing multiple angles of the same drone, finally revealing what many analysts had suspected but could never confirm. The gimbal system auto-rotated internally to shield the underside 360 lens, folding in such a way that pilots never saw it unless it was active mid-air. The hidden upper lens invisibly faced forward, recording traditional FPV angles while awaiting activation for panoramic capture. This was when DJI aficionados began to connect the dots. The drone was not an Avata 3 refresh. It was something fundamentally new, entirely re-engineered, ecosystem-altering, and strategically timed. The product name emerged later through another verifiable leak from a label photo that strongly indicated DJI was ready to finalize the packaging stage for a new flagship, the DJI Avata 360. A drone that integrates a 360 camera module but will also feature a rapid switching gimbal, capable of repositioning for pure FPV flight mode by mechanically rotating 90, while using both spherical lenses for open-gate 360 recording. Unlike static action drones or cinematic camera drones, this new system is expected to stitch two hemispherical 4K images into a single, AI-driven 8K panoramic video while rendering the drone body invisible during optical blending, enabling the real superpower of 360 capture, choosing any angle in post-production without reframing or needing secondary flight passes. This mode will also be heavily supported by an omnidirectional, software-enhanced obstacle detection system fed by a combination of onboard sensors and the camera optics themselves. delivering collision awareness without adding external sensor weight corners on the airframe. Analysts believe the design language broadly follows elements from the Sony Alpha Rumors community source, having validated the body silhouette similarity between the A75 camera body design and recent industrial patterns seen historically in Sony mirrorless hardware, especially around stabilizer armatures, thermal dissipation, and the articulating panel architecture. DJI's confidence in releasing such high-complexity hardware so boldly is not accidental. DJI was forced to mature rapidly in this space ever since the re-emergence of strong competitors such as Nikon and Canon, aggressively iterating sensor architecture, stacked capabilities, and oversampling throughput on their mirrorless hardware, raising the performance expectations for hybrid capture devices at the very same price band. DJI is targeting sub-$3,000 prosumer creators. DJI leadership has understood for years that camera technology and drone technology must talk more intimately at the silicon level, which is why one leak that excited hardware engineers most was the claim that the Avata 360 prototype will be the first DJI drone to integrate an AI-dedicated neural chip fused directly onto the main CPU package, effectively forming a system-on-a-chip architecture with reduced intermodule latency. Following industrial philosophies similar to the M-series, unified architecture pioneered by Apple engineers combining neural accelerators, hardware encoding modules, AI segmentation logic, and RAM into a single chip communication fabric. This kind of architecture benefits aerial capture even more than mobile or desktop workloads because in FPV maneuvers every millisecond matters. The difference between tracking, reliability, and subject estimation failure is latency. Sensor communication overhead, predictive data exchange, memory caching, stitching lag, and encoding bus congestion. With fused hardware, the camera feed can be encoded with dramatically lower jitter. The pilot viewport stream can remain high fidelity even while the 360 camera system is actively stitching frames at 50 FPS. The object tracking algorithms can operate without stutter mid-air. The flight control logic can communicate with smart modes at lower overhead, improving PID stability. The HDR bracketing system can run parallel to visual scanning input layers, and dynamic gesture tracking or voice command functions can coexist without module crashes or overheating CPU-level throttling. Theoretically, the Avata 360 could even implement action priority shooting modes, similar to cinematic workflows invented for sports photographers, provided DJI chooses to expose the modular OS hooks via firmware protocols that empower developers to build tracking macros, lave signal telemetry overlays, subject segmentation classifiers, low-latency wireless file transfer, motion priority calibration, LiDAR-assisted anti-collision logic, neural anti-alias oversampling layers, and optical sensor experimental enhancements historically unseen on G-portable drones. Leaks also indicate DJI intends to support several accessory bundles depending on pilot skill sets and ecosystem lock-in. DJI's most affordable kit may resemble a FlySmart combo, likely consisting of one battery pack, accessories, the motion controller module, and the goggles hardware set. The potential goggle types may include either the more cost-friendly DJI Goggles N3 or the premium-grade immersive pilot headset hardware known as DJI Goggles 3. The motion controller expected to ship with FlySmart combo packages will likely be the latest generation of DJI's handheld spatial flight controller, DJI RC Motion 3. On top of that, seasoned pilots who desire total sensor shutdown for manual mode flight may still continue using the separate FPV joystick hardware coined the DJI FPV Remote Controller 3, sold individually at an approximate trade price of around $200. A controller that is not bundled to keep combo kits cheaper while maintaining modular ecosystem compatibility for pilots who already invested in DJI control hardware. Beyond these FPV options, DJI is also expected to offer standalone drone packages that appeal to creators who don't need controllers at all, depending instead on computer vision gesture tracking or mobile app control. These will likely pair with the DJI Fly smartphone application. enabling one-touch active track cinematic automation payload, object orbit mapping, post-frame sampling recovery, omnidirectional anti-collision toggles, voice command runtime, low orbit detection stitching, spatial orientation balancing, tracking linearization, spherical gimbal sensitivity calibration, environment scanning algorithm reweighting, signal reprocessing latency minimization, haptic camera control viewport handling, and fallback manual mode UI architecture endpoints. DJI engineers will also likely bake transmission synergy from its long-range video protocol system O4 Plus, which offers up to 20 km signal range, far longer than its previous transmission module, delivering more reliable long-range stability, which is crucial, especially for panoramic capture or harsh terrain FPV flight passes. If battery endurance scales 20% higher than the Avata 2's runtime of 23 minutes, analysts expect about 25 minutes of endurance, translating to potentially 400 g total takeoff weight compared to Avata 2's 377 grams. Since 8K capture generates extremely heavy files, DJI is also expected to increase internal storage from 46 GB to 128 GB, with expanded SD card support for extended filming. Meanwhile,